7-3 आज सुबह 10 बजे तक ड्यू टाइम।
कौन सा 7-3 क्या है?
पुराना नॉर्मल
क्या
साइन नॉर्मल,
साइन का नॉर्मल
इनवर्स
वो तो कब का हो चुका है,
ये नहीं था
सोल्यूशन दिया था उसका।
और उसमें सबमिट नहीं किया तो खुद नॉर्मल सॉरी।
ओके सो योर बट ना चाहिए था ना, अभी दे दीजिए, पोस्ट कर दीजिए। सो आई डिस्कस्ड yesterday that the assignment should be given which is, so you did the sinusoidal regression, right, using least squares and minimum solution, and yesterday I told that you should do it for gradient descent, how to optimize your weights with gradient descent. Did you do it? It was not posted. Did you do it on your own? No. Okay, so let's go to the previous assignment where you have to estimate the weights using squares and minimum solution. Do you have any questions or doubts there? So you've already submitted the assignment. How many of you did it completely? How many of you were able to do the other parts? How many of you were able to do the advanced also? Advanced parts, which means by changing your capital N, what is the performance? By changing your capital D, what is the performance? So only three people. And what are others? So how many of you could not complete all the parts, even the non-advanced parts? So how many of you could not complete all the parts? So please ask questions. Why could you not complete? Tell me a function and we can discuss that. Since the deadline is almost, I think, already over, so we can discuss the solutions now.
Sir, can you please explain the previous question? This part.
For regression, what activation function to use?
Can you please repeat the whole?
Yeah. So for regression, the question is, for regression, what activation function should we use? So the answer is, okay, so in neural network you have hidden layers and then you have output layer. In the hidden layers, whether it is classification or regression, you can use any non-linearity, any activation function, does not matter. You can use sigmoidal, tan inverse, tan H, ReLU. People mostly use ReLU because of the derivative is a nice thing, nice function. So you can use any activation function for the intermediate hidden layers. But for the output layer, you have to be careful. So for output layer, you cannot use softmax because that is not desirable for most problems. But you can use either sigmoid function if you want to limit your values between 0 and 1, or you can use no activation as well for your regression problem, right? Because you want a continuous value between some range, so you can as well leave it open without using any activation also. You can do with your neural network model. Okay, so coming to the assignment now, please ask questions. Please ask questions. Yes, please. Ask questions now. Where did you find problems? basic Python problems, advanced Python problems, conceptual problems, any kind of problem, please raise your hand and ask the question. No problem. I mean, I am not. Yes.
When we are
Okay, please ask questions in this problem. His question is, when you are estimating your weights, you need A and YD. What are those, right? Okay. So we discussed that in a linear model, it's there also in the beginning. Okay, in the linear model, Y is W0, W1, W2, etc. like that. I can write it in a matrix form. How? So I say my Y is equal to can I write it like this? 1x, x square, so on. Right? I can write it like this. Let's say when I get many samples, I can also similarly I can open this up. Right? This is my A. This is my W. Right? So corresponding to Y, this is Y or Y hat. Corresponding to Y hat, I have Y desired. So my Y desired is correct? So these are your inputs because I will estimate my W as a the least square solution. Right? So you know now what is your A, what is your Y, you know everything. Correct? Any questions here? In your code, you already have a function to generate A, called create A, and that will return you the A. Please ask questions. So Sachin has posted the next assignment too. This next assignment is about training this model using gradient descent algorithm. So that will be your fun because you will see different challenges there. And there was no quiz today. Why? Huh? We can take. Fine. So since you don't have any doubts, so what we will do now is we'll go to the next topic, which is using libraries in Python. So we have got very good neural network libraries in Python. I have to find out where is that. Okay, so this is about Keras basics. Okay, so we're not going to study there's a library called Keras which has neural networks which we can use for our machine learning. So today we are going to learn about dense layers. What are dense layers? Dense layers are simply what we have seen. You multiply your weights with the input, that is a dense layer. That is called, technically this is called a dense layer. Just multiply your weights with the input. And then you can take any nonlinearity, be it sigmoidal or ReLU or tanh. So, and we will do this with a toy example. This example considers data like this. I will just think it is done. Where is the plotting? This is much simpler to see. Okay, so I have generated samples. Okay, so we saw in our presentation also, we have samples like this. For classification, we have samples like yes. For classification, we have samples like this. We have x0, x1, and so on. And we have desired y. And then we have estimated y, which we estimate from the neural network. So similarly, in this problem, we have got our data. So x is my data, which is input. Okay, let me show you here. This is how my data looks like. I have got two classes like this. One is the blue points, one is the green points. Right? You've already seen this example before in terms of lotuses and roses. Right? This is my data. So what I have done now is so I need to do some things like first I need to normalize my data. Okay, I generated my data first here. Then I have to do one-hot encoding. My Y's are, let's say, Rose, Jasmine, and then I convert them into numeric form 0, 1, 2. And then I do one-hot encoding 1, 0, 0, 0, 1, 0, 0, 0, 1. This part you have already seen. Like, you know, we have already done assignments on 0, one-hot encoding, right? This is clear. Next is input normalization. We discussed this point that your inputs, you subtract the mean and divide by the variance so that it lies in a convenient zone, which is like, let's say, of the range of -1 to +1. It can be a little bit up or down, it can be from -2 to +2, but roughly it is of that range. So then your model can learn it very nicely. So you normalize x, and then, okay, plotting is done. Now next step comes, which is very important. You create your network. So what kind of network do I need? So here, I need this kind of a network. I am using, so my x is like this. I have my x. In this case, my So I have only two of these. And then I have a hidden layer. So in the hidden layer, I have, let's say, so how do I do it in Keras? First I say import Keras. I import the library which I want to use. And in this library, I have many important functions like keras.layers.input. This function will create an input layer. My x is the input layer, so this is the input layer of shape nx. Nx is 2 here, so x is my input layer. Then next, y is the dense layer of 20 neurons. And the activation I am using is the ReLU activation. So here I have got 20 neurons. And the activation here is the ReLU activation. So on each neuron I am applying ReLU. Right? And then my final output layer is a softmax function. So how many neurons I want? That is ny. Ny is equal to the number of classes which I have defined above. Ny is the number of classes. And then I have activation softmax. So here I have, let's say, 2 or 3 classes. Let's say 2 classes here. And so these are the bulbs. Y0, Y1, and I have applied a softmax nonlinearity. So means my Y is equal to softmax of H. H is the simply the weights time the output of the previous layer. And then that's it. This is my output. Now I have a function called model, which will put everything together and create the model with input as x, output as y. So I create a model with this as my input and this as my output. This whole model is created. Right? And then I compile the model. While compiling the model, I specify what loss function I want, what optimizer I want. Here I am using gradient descent with eta equal to 0.001. LR means the learning rate or the eta. You remember that, right? And the loss function is categorical cross entropy. And the metric which it is printing on screen is the accuracy. I can use precision, recall, anything, but I am using here accuracy because my data is balanced. And then I want to print the model. I want to see what model it has created. So I did this model.summary will print what model it has created. This is the model it has created. The input layer has 2 neurons. Dense layer has 20 neurons. How many number of tunable parameters? Remember we did this exercise last time. Each neuron has 3 inputs, means 2 inputs plus 1 bias 3, and 20 means 20 times 3. So you get 60. You remember this exercise we did last time? So the same thing. And then we have the second layer, which is the output layer. It has got 2 neurons and number of tunable parameters is 42. And then it gives me what is the total number of parameters, total number of trainable parameters and non-trainable parameters. What are non-trainable parameters? For example, I want to fix some layer. I don't want to change it. Just do not update the weights. I can say freeze this layer. Then those weights will not be tuned. Right? So they will appear here, non-trainable parameters. But I do not have any non-trainable parameters here, so don't worry about that. Next, I want to plot my model. How does it look like? This is optional. You did not do it always. Just for fun, you want to see what your network looks like. Okay, then you can say, you can use a function called plot model. It will plot the model like this. input layer has 2 neurons, dense layer is the first hidden layer has 20 neurons, and then the output layer has got 2 neurons. Okay. Now this is the main function which does the learning. Here I am actually learning from the data. I feed the X frame, the Y frame, number of epochs I want. Did you discuss the concept of epochs? Yes? No? Okay. So you remember last time we discussed about the gradient descent algorithm. So what is gradient descent? You take a y, you have your x and y, right? And you train your weights by using dou e upon dou w, or basically your w old. Sorry. You say your w new, w old minus eta times. Right? So the algorithm was, you do it for the first point, then the second point, and third point, and all these points, and then that is one epoch. When you consume all the samples, so you do it for all the samples, it is called one epoch. So when you take one sample, update the weights, take second sample, update the weights, take third sample, update the weights. In this way, when you complete all the samples, that is called one epoch. Since this is an iterative method, it won't be converging immediately, right? It will take some more time to converge. So then you again start taking the samples, and that is called the second epoch and third epoch. So one epoch means when you see the entire data once. So in this way, you specify I am running it for 5 epochs, let's say. And here I have taken batch size. So what is the batch size? Batch size means I do not update my W for every point. Yes, good. So I compute my dou E upon dou W for, let's say, a set of points, let's say 200 points, and then use those gradients to update my W. Okay, let me write it down. Number one, choose, okay, let us say we have 1,000 samples in the beginning. We have 1,000 samples. Choose, first is make 5 batches of 200 samples each. Number 2, for each batch, compute right, because we do summation over all the samples. So these samples are only from 1 to 200, and then update W.